pleasure to welcome you on Wednesday afternoon with such a strong audience to my presentation with the topic of a comparative evaluation of CatBoost decision trees and expert intuition to predict durations in the pre-design phase. My name is, as you already mentioned, is Svenja Lauble, and I wrote the paper together with my two co-authors, Dominik Steuer and Shervin Haghsheno. We are both from the Karlsruher Institute of Technology. So, time schedules out of the early design phase are planned on a very rough level. So they are planned very often on a weekly or even on a quarterly level. So they're planned very roughly. But even if when they are planned very roughly, it is important to have as accurate as possible time schedules, as they are the basis for the following project. So for example, they are the basis for investment decisions, for doing resource decisions. Then they are further on the basis for a lot of contracts. So they are also coordinating all your partners. And then further on, they are not just like defining hard factors, they are also defining soft factors like the project atmosphere. If you're planning too short durations, there's time pressure for your trades and they are not feeling very well. And lastly, it's also defining the project success as it's setting some kind of benchmark for the following project. But there's a very big problem, because in the early design phase, there are not many information available about your project to do accurate predictions. This is why in practice, very often experts are doing the predictions based on their last few experiences. And there, Kahneman and Tversky already stated in 1977 that humans tend to do underestimations. So they are saying, okay, maybe the last project was not that good, but in the next project, this problem will not occur. So they're taking rather an internal view and analyzing the last few projects rather than taking an external view and analyzing a lot of different projects to get an objective result out of it. And this is why in research there's a lot of investigations in this topic. So in my literature research, I found really like 400, 500 or even more studies about different kind of statistical models to a little bit more fancy and advanced models. Here in the table, you can see different kind of models other authors used to predict in the pre-design phase durations for construction projects. So starting from simple correlations and then going on to artificial neural networks, to decision trees and other kind of models. In a previous study, I could already show that in comparison to these kind of models, decision trees show very promising results, as they can work with a limited number of project data. So for example, just with a few hundred of documented projects and not like thousands or millions kind of projects, which nobody is having at the moment. And they can also work with missing features and also with categories, which is very important when you're trying to describe your project. And then I was asking myself, so there's so much research in this topic, but nobody is using it. Why is it like that? Is it that still the prediction accuracy of the experts is so much better that nobody want to use these kind of models? And this is then how I came to my research question, which is basically, which one is better? Is the expert intuition having a higher prediction accuracy, or is it the CatBoost decision tree? Further on, I also wanted to analyze what kind of features are further on supporting whether I should do a prediction by an expert or whether I should do the prediction with an analytical model such as the CatBoost decision tree. To answer this research question, I used a public open dataset from the city of New York with 367 projects. There were documented 14 different kind of features, like the project category describing if it is a school, if it is a road, or if it is a park, for example. Further on in the dataset were information about the budget and also about changes like changes in cost and also changes in time. I enriched this dataset with market external features describing the economical and political situation about New York in the city the project was starting. These Features were, for example, the inflation rate or the number of building permits. And then in the table on the bottom, you can see like the key figures about the duration within the data set. There were, in average, was the initial prediction of the construction project was 2,291 days from the design start until the handover. And the finalized duration was a little bit higher. It was 2,723 days, so around 500 days later, which is also supporting the statement from Kahneman and Tversky that people tend to underestimate, really in average, the durations they predict by themselves. And then following, I used the following methodology. So I first assumed that the first prediction within a dataset per project is the estimation by the expert. This one then I compare to the realized duration, like I just did it a moment ago, and said, okay, this is the error by the expert. Then secondly, I trained the CatBoost regression model to make predictions about my time from design start until handover. This one, again, I compared the prediction to the realized duration to get the error by the CatBoost. With these two kind of performance indicators, so that I used the mean absolute error, I could say per project if the prediction accuracy was higher for the export or if it was higher for the CatBoost. Then further on, I labeled again the dataset with this information, so if the prediction should be done by the CatBoost or by the expert. I trained another model, a classification model, to decide whether the prediction should be done by the CatBoost or by the expert. And this training or this classification model, I then further on analyzed with the Shapley framework what kind of features are important for this decision. I now want to show you two main results, and for everything further on, you have to read my paper. So for the training, the CatBoost, I subdivided the dataset further on in 4 sub-datasets. Firstly, I said in one dataset, I will take the information about changes, and in one, I will not take it in. So the first situation is if you're in the beginning of a project, of course, you do not know what kind of changes there will come. And the second one, when you're in the project, maybe you already know something about the changes. And then also I once added these external market features and once I didn't edit it. So then in the end I had 4 sub-datasets. These sub-datasets I compared to the expert, and as you can see is that the mean absolute error is for the CatBoost always much lower. So you could say, of course, yeah, in average, a CatBoost is doing better predictions and should be really used in practice. If you then further on analyzing the different kind of sub-datasets, you can see that the market external features are supporting the prediction accuracy. So if you know something about the global uncertainty, you should add it to your dataset. But then further on to my second result, if you're analyzing the percentage in which you should prefer whether the one or the other one, the result is not as clear as you could think about it from the first result. So there are differences from like 15%, 40, 45 to 55 to 60%. So this gives a hint, in my opinion, that not the CatBoost alone should do the prediction, rather than both should work together. So I would say or recommend there should be done in future a human-machine collaboration. If you then further on also try to analyze the 4 kind of sub-datasets, you can see that information about changes, so when you're within your project, the CatBoost is slightly preferred, rather than if you're in the beginning and you do not have any kind of information about project changes, about the future insecurity in your project, you should rather take the expert. So now summing everything up, I wanted to show in my paper, or I could show also in my paper, that CatBoost decision trees can support in average the high outliers which human experts are doing, but still, machine learning models such as the CatBoost should not be done solely alone. Rather, there should be done a human-computer collaboration, and it is also important to analyze what kind of information you have and in what kind of situation you are. Are you in the project beginning, or you just want to update your time schedule? And yeah, thank you very much for your attention, and I welcome any question you may have.